In the last video, I looked at the graphs of the sine and cosine functions, and we looked at the domain and range and related topics. Now we want to look at the graphs of the reciprocal functions, secant and cosecant. Now the graphs are related, so just as a review, we're going to do these in the calculator, but just to show you how these are related, we saw that the cosine function had a period of 2 pi or 360 degrees, the same thing for cosine. And the graph for the cosine function went something like this. See if I can get accurate here. A little hard to do it with this little 2 here, but anyway, so something like this. Okay, and then it repeats over here on this side, and then it continues on to infinity. But from 0 to 2 pi in radians, or 0 degrees to 360, is the typical period of the cosine function, and then it repeats. Now if we look at secant of x is 1 over cosine of x. Okay, so just like with rational functions, typically rational functions have vertical asymptotes for values that make the denominator 0, but not the numerator. So notice here, we had said that the domain, we had mentioned when we looked at the graph of cosine that the graph of the cosine crossed the x-axis at odd multiples of pi over 2. That is pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, and so forth. So this is where this is the secant that is undefined. Whenever this cosine of x is 0, so that would be at pi over 2 and 3 pi over 2. We just look at one period. So we would expect then for the graph to be, or the function secant of x to be undefined there. So we could actually draw a vertical asymptote passing through the point where x is equal to pi over 2, and also where x is equal to 3 pi over 2. So this is a broken line. Okay. So the domain of the cosine function was everything between -1 and 1. We saw that in the last video, including -1 and 1. Actually, it turns out that the secant of x, or the function secant of x, would look something like this. Okay, it looks like little parabolas that open up and down. So this would go like this. And it touches right there at that value here at 1, here at 2 pi and 1, and here at the bottom here at pi and -1. Okay, now if I go ahead now and erase or remove the cosine function, I get the graph of the secant function. Okay, so notice it goes from 1 on, and then at -1 and everything below, nothing in between here. So that's why we say that the domain goes from -infinity to -1. The bracket means that -1 is included, and union, or also included, are the values from 1 to infinity, including 1. That's why the bracket's here. And of course, because of the functions undefined at multiples, or I should say odd multiples of pi over 2. That's what k here. So x cannot be k pi over 2, or k is an odd integer. Okay, so that excludes all the multiples of pi over 2. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2, and so on. So that's what your graph looks like. Okay. Now if you're going to do this, in the calculator, okay, so the number 1 here is representing the graph of y equals secant of x, okay, by that is 1 over cosine. So if I go to zoom, say 7, and I do have set this, I have this set to degrees here, even though I have the main domain range over here in radians and real numbers. So if I hit number 7, zoom trig, okay, there's what the graph looks like. Okay, I have the 1 period here in my diagram here. Okay, so right here you can see the part I have is here, this one here, and of course this over here. Of course the calculator doesn't show you the asymptotes, the vertical asymptotes, but they occur at odd multiples of pi over 2. Okay, so I'm just showing you one period. Most instructors will sometimes ask you for a sketch of the graph without the calculator, and they'll ask you to give 1 period. Okay, and that usually pertains to the main period. So sine, cosine, secant, cosecant, they're all going to have a period of 2 pi or 360. Okay, so let's clear this. Now, let me clear this here. Look at the next one. Okay, if we want to look at the graph of y equal cosecant of x, that's related to the graph of sine of x, which is the reciprocal is 1 over sine. Okay, the reciprocal functions. Okay, so 1 over sine of x and cosecant of x, the reciprocals. Okay, so for the graph of cosine, okay, we're going to go for 1 period from 0 to 2 pi. So it touches the graph here, then it rises up to 1, and it crosses back at pi, goes down to a minimum value of -1 there, and then it goes up, touches right there. Okay, so we saw last time that the graph of sine of x, and that's what this is. This is the graph of sine of x. Cross the x-axis at 0, pi, 2 pi, 3 pi, -pi, -2 pi, so at the multiples of pi. Okay, so that's when cosecant is undefined, when sine of x is equal to 0. Okay, because you have a 0 in the denominator. Okay, so that's why over here for the domain for the cosecant, we say the domain is a set of x such that x cannot equal to pi or k pi, where k is an integer. Okay, so it means we're excluding all the multiples, not necessarily odd multiples, but all the multiples of pi. Okay, so again, because it's undefined at those values, you would expect then to have asymptotes at those points. So here, vertical asymptotes. Let me draw this as a broken line here. And one over here. Okay. And of course the y-axis is also an asymptote. So this graph then would look like this. You go down, touch that high value right there, and then go up like that. Then over here, go up, touches there at 3 pi over 2 and -1. It approaches the vertical asymptotes on the left and on the right here. And then if I go ahead and delete the graph of sine of x, this is the graph of y equals sine of x right here, 1 period of it. And of course the graph repeats. Okay, we're just doing 1 period here, so if I remove this, that's your graph. Okay, so the point is you can get the graph of the secant and cosecant of x if you know the graphs of sine and cosine. Okay, this way. So again, the domain excludes the multiples of pi. Okay, x cannot equal to k pi, for k is an integer, because those are the values that make the sine of x over here 0, which means the cosecant is undefined. And you can see again that the range will go from 1 on and -1 to negative infinity over here. You got this right there. Okay. Now if you want to look at the graph on the calculator, okay, so now we want to graph this one, so let's select that one and select this one, 1 over sine of x, which is the cosecant of x. Hit enter, and then again we'll do a zoom 7. Okay, so this is what I have here. So this right here on the right is would be one period from 0 to 2 pi, or 0 degrees to 360. Okay, now you can also do a trace on these. So if I hit the trace button here, so notice then at 90 degrees, we would correspond to pi over 2. The y value is 1, so okay, so that would be this point right here. Keep going here. Okay, so at 270, that corresponds to 3 pi over 2 over here in this chart that I have with this graph. It goes down to -1. So this right here is the point. This right here is the point 3 pi over 2 and -1, and of course this one over here is the point pi over 2 and 1. And again, it approaches the vertical asymptote over here on this side and this side. And of course, this one approaches the x equals 0, of course. That would be radians in this case. It would be the y-axis, and that's another vertical asymptote. Okay, and this gets repeated. So again, the graphs of the sine, cosine, and the reciprocal functions, secant and cosecant, have a period of 2 pi. So from 0 to 2 pi is considered the main period, or from 0 degrees to 360 degrees. Okay, we'll continue with another video next time. So thanks for watching. We'll see you next time.